Welcome everybody to a new example. So as you can see in this one, we have these two characters that's fighting each other, and we managed to extract some cool effect of these tentacles, and all being rendered in karma inside a cup of glass, as you can see in the render. There's some slow down, couple of frames with some reflections, and it's been affecting the particle, so they slide on the surface of the glass, as you can see. And we have this magical smoke that's being sourced from specific area according to the velocity. So let's go down to the scene file. So this is the scene file. The animation is not included in the file in my bathroom, but you can find it in sketchfab. So this is the animation. We added an FBX character animation with joint deform and some retiming. After that, this is a radial grid, and we extracted it just to prepare the glass later on. Here, if you want to add some sand, you can add it, but I didn't include it, as you can see here. Now the character, I peek a little bit, then I split them accordingly. So this is vellum grain, as you can see, and it is fixed, it's not moving. I made a group and color and change the ID to keep it, but I use as IDM, so vellum will not error out if I just keep it an ID. Then I add an attach constraint, and this attach is connecting the nearest grain to this skeleton. So if you go upstairs from this object, this is the skeleton, the third output. Clean it, sample it, because it have less points. Then I split it, I make a group and split. This one is moving, so this will write the animation of the vellum grain. Same thing goes here, and we merge. So this is merged, and here the vellum solver. Inside the vellum solver, we have the glue constraint in each frame and for each skeleton. See? So they are separated, and here when they are attaching to the surface of the glass, this one, this fix, it will compute according to the open cloud of the points, how we can manipulate the velocity according to the age, and then we are creating density according to the speed, the curve, the direction. So here is the parameter, and when we separate the points, we're using this fix, so it will be like a collection of points together according to the calculation here and the clusters. And in this one we are calculating the hit according to the time and the point numbers and the size of the collision. And here we are calculating also the slidings when they hit the collision of the glass, how they will slide. And then we are putting groups, and we are calculating the damping and the stiffness of these grains. Then we save it. So this is the result. The more points you add, the better the calculation. So this is one frame, and as you can see the grains. Let's call it 50. And this is when they hit the glass, as you can see. Here we are calculating the velocity, we are fit range, the dW, the length. And here we are calculating the nearest point and the furthest point and the gradient. So, and next we are after auto fitting, we are calculating the speed weight and the distance weight, so we can get up some more parameter. I'll show you this one. So we can decide where we want the smoke to rise from as a control. Also we can use these in the shader. See? So the higher intensity, the more probability, than the higher value of the output that we need from density for the subsurface. All of that we can use it from this parameter. And then we are surfacing, and we are using neural point surface as a smooth. This is the first one. So as you can see, very smooth. And on the other hand, we are creating the smoke with the velocity also all being rasterized. So here we are calculating the density according to the previous controls and the table that we created for the distance, the time. And then here we are doing the collision VDBs, adding them to the Pyro solver, and then we cache. And this is the result, very thin smoke. And here is the first one with the preview. So we can add emission so it's more bright. Then we go to the stage and we add all of them. The material also being done, and this is the result. Yes, you can join me on my Patreon. Hopefully you will enjoy exploring the scene, building on it, and have more ideas. Currently I'm doing this one now, but it's still rendering. This is MBM simulation also, still running. Have a good day. Thank you.